In this episode, we're going to use Heroku to bring multiple technologies together, from Node.js for web applications through to Rust for highly performant APIs, and even a microcontroller. So let's get right into it. Here are a few requirements to guide our demo today. First one being our IT infrastructure should support the growth of the company. Our second requirement is about cash flow and making sure that we do not overinvest unless we have the demand for the services. And lastly, we need to make sure that we comply with all the regulations. We have three main actors in today's demo. First one being Nicole, who is an experienced JavaScript developer and uses React for front-end and Next.js for back-end development. Then we have Elijah, who is a cross-platform developer with experience in Rust for API development, as well as C++ for device-specific applications. And finally, we have Diane, who is a customer of our company. Here is what we want to create in today's demo. A web application that is accessible by our customers, and a highly performant API layer that we can use to store the security sensor information. Let's add the technology components and focus on the web application. Nicole is going to use React and Carbon design system to develop the application for the front end and bundle that up using Webpack. And she's also going to use Next.js, which is a Node.js framework for all the backend components. Let's move to the security logs application layer. This is where Elijah is going to use his Rust experience to deliver an API layer that is highly performant and make sure that he can deploy that using Docker. That API layer is also working with a Postgres database in the backend to make sure the data is stored and available as required. We are using Heroku to expose our Postgres database as GraphQL APIs for our backend integrations. And last but not least, I have put together a simple circuit and used Arduino as my microcontroller to showcase the Sensor Hub integration with this API layer. So what do we need to implement this architecture? Let's look at your applications which sit at the very top. First of all, you need some servers. You need to make sure that they talk to each other, so you have some networking. You need some storage to store the data, and you need to make sure you virtualize your operation system so you're not running the applications directly on the servers. Now that you have somewhere to run the app, you need to think about lots of different aspects of your applications. I'm not going to go through every box, but you can see it's very complicated. And what Heroku does, it removes all that complexity by giving you a platform as a service solution, which is hosted on Amazon Web Services. So in summary, Heroku provides a secure, enterprise-grade platform for organizations of any size. This platform is handling billions of transactions per day, has millions of apps built on top of it, and also has more than 175 add-ons to integrate with partners. And on top of this, Heroku provides a set of features to enable you to comply with industry regulations. Let's jump into the platform and see it in action. So the very first page you're going to see is the dashboard. And that dashboard depends on the team you have logged in as. And the team provides a collaboration environment for you and your working group. In my case, I have logged in into Salesforce Explain team, and I have two applications that I have access to. But what I'm going to do is I'm going to create a new application for my front-end development. This is the web application that serves the analytics on device logs. And I want to run it on my local machine to make sure everything is working before I deploy it to Heroku. I have configured Heroku Connect to connect my Postgres database with CRM data, and I'm bringing price, description, and even image data from my Salesforce CRM into this platform. In addition to this, I have also created a device log table that I can use to aggregate the analytics information and show it on this page. There are only two commands that you need in order to create a new application. First command is a create command, and it requires two input. One of them is the team you're going to deploy the application to, and the second one is the name of the application. In this case, I'm using Security Portal Next.js as the name. You can use Heroku point-and-click configurations to fine-tune the application. That can be resources, you can look at analytics, and you can also fine-tune the access and settings. Our newly created application is a simple application without anything in it. Let's deploy something to it. So our deploy command is going to use the build in Node.js to build the package, and then started with a start script. And the way you define that is in a proc file for Heroku, which says what script to run when your application needs to start. And the second command we need to run is a git push Heroku master, and it pushes your code into the master branch of your Heroku repository. And Heroku recognizes that change, which then triggers the build and the start of the application on its platform. So let's look at how the application looks like when it is deployed to Heroku. In the activity tab, you can see that it is being built successfully and deployed, and it's going to look exactly the same because I used the same source code. Nicole is very happy with the web application deployment because she did not need to know anything about the infrastructure, how to manage networking, and how to deploy to hybrid cloud because Heroku removed all that need. Let's change actors and have a look at the platform from Elijah's point of view. He's a cross-platform developer who needs to create a highly performant API. That application is connected to a Postgres database, and that Postgres database has a set of features. For the higher tier of the Postgres product, you can have automatic rollbacks. You can also have your manual backup whenever you want. Data clips are also a way to share data with different APIs, and for my case, I'm using it for a GraphQL aggregation layer. Another add-on I want to show you is Heroku Connect. And this add-on integrates Salesforce CRM data into our Postgres database we have defined. In our mapping, I am bringing product and price book information so that I can expose it into our web portal for our customers. This integration can also work bidirectionally if you want to send data from Postgres to Salesforce. There are hundreds of add-ons on Heroku, which enhance the capabilities of your application. It can be as simple as data stores or as complicated as video processing. For example, in this demo I showed you how you can use the Heroku Postgres add-on, which was all point-and-click configuration. Now that we understand how to deploy an application and add add-ons to our application, let's look at our runtime environment. Dynos in Heroku are the containers that run your application. The price of each dyno type depends on the performance that it provides. You can scale your application by increasing the number of dynos that are running for that application, or to change the type of dynos that are running that application. The higher tier dynos also provide auto scaling, so then you don't have to manually set these values. Heroku also takes care of all the load balancing for the dynos you have chosen, so you do not have to create a load balancing engine for your applications. Nicole used out-of-the-box build packs of Heroku to deploy the Node.js application. But for Elijah, this is a little bit different. Elijah is working with a Rust application, and he wants to control everything that is running in a container. Let's use cargo commands to test the application locally before deploying it to Heroku. I'm going to use Thunder Client to make an API call to my local endpoint and make sure that the data is saved into our Postgres database. Now that we know the application is running properly, let's have a look at the Docker file. This file consists of two steps. The first step compiles and builds the program, and the second step is a Slim container that runs the application for us. Just like our Node.js application, you can use git push Heroku master to deploy this container-based application. And then Heroku is going to pick up your Docker file and run through the commands you have defined there in order to compile and run the application. After a few minutes, Elijah has been presented with a newly deployed application. You can use the same features that we saw on the other application to change the dyno types to make it more performant, as well as using auto scaling so we can support high demand when needed. Now let's test the API by using a circuit that I've put together using Arduino as my microcontroller. The logic in the code is very simple. There are two switches on the circuit. One of them creates an error log and the other one creates a motion detection log using our API that we just deployed. Let's press the error switch. We're going to make an API call and receive a response. Let's do the same thing with the motion detection switch. New log IDs that we see in the terminal box are the Postgres record IDs that the API is creating. So everything that goes from this device to the API is stored in our Postgres database, which then can be exposed to the customer portal we had as part of our Node.js deployment. In summary, Heroku removes all the complexity of cloud application deployment. Its enterprise features, such as private space and shield, enable you to stay compliant with your industry regulations. And finally, its pricing model prevents overinvestment in services that are not in use. Until the next episode, hope you have a good week.